Hey guys, Dr. Brown here, and tonight we're looking at the integral of cosine x raised to the n. You'll recall we've had some previous videos where we did sine squared x, sine x cubed, I should say, sine x squared, sine x cubed, the integral of those, and then we did integral of sine x raised to the n, and then we compared our answers that we had previously to the integral of sine x to the n. Well, we've gone through cosine squared, the integral of cosine x squared, cosine x cubed, and now we're going to do the same thing with cosine x to the n. So hopefully we can work through this and then compare what we had previously to the results here. Okay? All right, let's get after it. I enjoy doing things like this. For some odd reason, I don't know. Okay, we're going to take the cosine and rewrite that. Actually, you'll see me do this a lot. Cosine x raised to the n dx. Okay, you're all aware this and that are the same. To me, it's just more clear because every other number or variable we look at, we use it in this form, not that one. But I get it why they say cosine x to the n. Okay, I mean, I understand why they say that. If they said cosine x squared or cosine squared x, cosine nx, that way you can tell it's that. Okay, enough said there. Let's get after it. Okay, I want to break this down into cosine x to the n minus 1 times cosine x to the 1. So, you know, if I have a to the n, a to the m, and multiply those together, that's a to the n plus m. Same here. I have cosine x in both, so now I have n minus 1 plus 1, it's just n. So this together is the same as cosine x to the n, and this fundamental move is the critical piece in my mind to walking through the problem. I think calculus is like that so many times. There's, you know, a lot of it's just algebra. But that one fundamental calculus step that allows the algebra to continue is the crucial one. And that's the crucial one here, at least in my mind. So now let's take and do integration by parts on this. Okay, so we have positive, negative. Maybe I need to move that over just a little further. All right, di plus negative. All right, so what are we going to put in here? Let's take the derivative of this cosine x to the n minus 1. Let's do that. Cosine x to the n minus 1. And we're going to integrate cosine raised to the first power, just cosine x. Okay? All right, so now let's integrate this. We bring the n minus 1 down. N minus 1 times cosine x to the n minus 1, which is n to the n minus 2, chain rule times the derivative of cosine x. The derivative of cosine is minus sine x dx. Okay? Now the integral of cosine x is sine x, because the derivative is minus sine, the integral is positive sine. Now then, what do we have? Okay, so we have I'm going to scoot over just a little bit. The integral of cosine x to the n dx equals, and I'm going to put my sine terms first, sine x cosine x to the n minus 1. Now we're going to look at the integral of this row. So I have a negative times positive. So I have a positive here. Positive, n minus 1 is a constant. Put it outside. Sine x times sine x. So I have sine x squared cosine x to the n minus 2 dx. So did I get all the terms? N minus 1 cosine sine squared. Okay, I have them all. Alright, so what do we have here? The integral of cosine x to the n dx equals sine x cosine x to the n minus 1 plus, I'm going to take this sine squared x and make that 1 minus cosine squared. And I'm going to break it into two integrals here in just a moment. 1 minus cosine, so I'm going to put the squared x here, it's not so cumbersome, times cosine x to the n minus 2 dx. Now let's distribute that cosine x to the n minus 2 to the inside and break that into two different integrals. Okay? I'll work with that just for a moment. N minus 1 times the integral of cosine x to the n minus 2 times 1. So cosine x to the n minus 2 times the 1 dx. Now I have n minus 1, but I have this is going to be a negative integral because I've got cosine of the n minus 2 times this cosine squared, and it's a negative here. Need to keep that n minus 1 to the outside. Okay, now you'll notice I've got cosine x squared times cosine x to the n minus 2. So now I have 2 plus n minus 2. So the 2's cancel. So this product gives me cosine x to the n. Okay, let's fill in the blanks over here. Cosine x to the n. Whoa, you can already see where this is going. So I have a cosine x, the integral of cosine x to the n here, and I have another one over here. Well, why don't I just add n minus 1 times the integral cosine x to the n dx to both sides, plus n minus 1 integral cosine x to the n dx. So I'm going to add that to both sides. These cancel. So now I have one of them here. 1 plus n minus 1 just leaves n. So I have n times the integral of cosine x raised to the n dx, and that equals sine x cosine x to the n minus 1 plus n minus 1 times the integral, this integral here, of cosine x to the n minus 2 dx. Well, I don't want to know how many n of them are. I want just one. So let me multiply this by 1 over n. So that cancels. Here's 1 over n. And I'll just divide that one by n. Be the same as multiplying by 1 over n. So these cancel. And that's what I'm left with. The integral of cosine x to the nth power equals 1 over n sine x cosine x to the n minus 1 plus the fraction of n minus 1 over n times the integral of cosine x to the n minus 2 dx. Okay, well, is that correct or not? that's the big question here. So that's a bad looking 2 there. So the point would be, could I plug in an n equal 2 or n equal 3 and get those results? So let's try that. Drum roll. Okay, so now we would have, let's let n equal 2. So we have 1/2 sine x times cosine x of 2 minus 1. So that's just 1. And that's plus 2 minus 1 over 2 integral of cosine x to the 2 minus 2. So that's to the 0. Alright, so this 2 minus 1 is 1. So that's just cosine x. 2 minus 1 is 1 over 2. So that's 1/2. Cosine any number, oh that's dx also. Any number raised to the 0 is 1. So this just becomes 1. So I end up with 1/2 the integral of dx. So what is that? 1/2 x. So we have 1/2 sine x cosine x plus 1/2 x. Alright, now you'll notice we have over here, let's see, what can I erase and give us some room to work? Maybe my cord will reach. We have, that integral is 1/2 x plus 1/4 sine 2x plus c. So that's when n equals 2. So we have the 1/2 x, 1/2 x, but you'll notice there's a difference in these terms. I have 1/2 sine x cosine x. Well, sine of 2x is 2 sine x cosine x. Okay, so this piece right here is 2 sine x cosine x over 4. So I have 1/2 x plus 2 over 4 sine x cosine x, which is 1/2 x plus 1/2 sine x cosine x, which is what we have here. Now you may be thinking, oh, well, how do I really know that? Let's take a triangle. Let's put in this area here pi over 6, pi over 3, and this would be a 90 degree or pi over 2. So pi over 6 is 30 degrees, right? Pi over 3 is 60 degrees. So I have a 30 degree angle and a 60 degrees. So this is twice that angle. Now we know if this is 30, this is 1 square root of 3 over 2. Maybe that's an old school way of looking at this, but back before we used calculators, we just knew the different sides, and you can try this in your calculator. Okay. All right, so for example, sine of x. Let's work with this 30 degree angle. If we said I have this situation here, sine of 30 degrees is opposite over hypotenuse. So in this case, 1/2 sine x cosine x. We're trying to say that's equal to 1/4 sine 2x. That's our question, right? Because we had the 1/2 x here and the 1/2 x there. So it's the other part of that equation that we're trying to say, does that work or not? Is it equal or not? Okay, so I have 1/2 sine of 30, which is opposite over hypotenuse, so that's 1/2. Cosine of 30, which is adjacent over hypotenuse, which is square root of 3 over 2. So this is square root of 3 over 2 times 2 is 4 times 2 is 8. Okay, on the other side, I have sine of twice the angle. So now we're dealing with the sine of 60 because it's twice 30. Sine of 60 is the opposite over hypotenuse. So square root of 3 over 2. Square root of 3 over 2. And that equals square root of 3 over 8. So we can see that this equation, and with n equal 2, ends up being exactly the same as that one, just in a slightly different form. Okay? Now then, what about the n equal 3? All right, let me clear out a spot here. And we'll just let n equal 3. So now n equals 3. I would have 1/3 sine x cosine of 3 minus 1, which is what? Cosine squared x. 3 minus 1 is 2. Plus 3 minus 1 is 2 over 3. Integral of cosine of x to the 3 minus 2, which is just to the first power. Okay, integral, we'll solve the integral here. Integral of cosine, derivative is minus, and the integral is positive sine x. All right, now what do we got here? 1/3 sine x cosine squared x plus 2/3 sine x. Yeah, if we were to multiply this one out, okay, if we multiply 1/3 sine x times, distribute that to the inside, so I'd have 1/3 sine x times cosine squared x plus the 1/3 sine x times 2, which would give me 2/3 sine x plus c. Yay. So 1/3 sine cosine squared x plus 2/3 sine x plus c. Okay, so we can see that this was in fact the correct formulation to be able to just plug in n equal 2, 3, 4 and work through that rather than having to do this and work out each one. Although it's fun too, I realize that. Okay, why are we doing this? I'm retired. No, actually I have spinal stenosis and I can't work, but I can do a 20 or 30 minute video. Go lay down after this is over. But I want to share just some of the things I've learned over my career so that together we can build a better tomorrow. You kids out there study, man, the opportunities with all the new technologies coming on, they're going to gravitate toward people that have good logical minds. So continue to grow your skills, okay? And you do that by practicing. Just like the basketball player, they don't just go shoot one free throw and then once they hit it, hey, that's great, that's good. The professional keeps shooting till he can't miss. And that's what you want to do. You want to keep practicing and grow your mind and enhance your skills. Okay, that's all for now. We'll talk to you next time. Thank you.